Welcome to the resource creation assignment for the out of class activity. So in the TPS section we dealt with the different blocks that is coming inside the DC regulated power supply. And in this section we are going to see the first block in detail, that is the rectifier section in detail. So now we are coming on to the rectifiers. So a rectifier is an electrical device that converts alternating current which periodically reverses direction to direct current which is in only one direction. This process is known as rectification. That is, AC current is having, it is like a sinusoidal waveform and it is having both positive and negative half cycles. And this waveform, which have both the positive and negative half cycle, is converted to a waveform which have only one direction. That is either the positive half cycle alone or the negative half cycle alone. Now we have different types of rectifiers. The first one we have is half wave rectifier. The second that comes is full wave rectifier. And the third one that helps for this is a bridge rectifier. Now we are going to see the half wave rectifier, what it is, how is it working. In half wave rectification process, either the positive half cycle or the negative half cycle of this AC wave is what that we get at the output section. It is either positive or negative half of the AC wave is passed while the other half is getting blocked. This is done with the help of the diodes that we have in the circuit, because we know that the diodes work only in the forward bias condition. So for cutting or blocking the negative half cycle, we are going to use it in the reverse bias condition. So because only one half of the input waveform reaches the output, it is very inefficient if used for power transistor. So in half wave rectifiers, either the positive half cycle or the negative half cycle alone is reaching the output. Now this shows the working of the half wave rectifier. This animation shows the input section. This shows the circuit, and next the section shows the output waveform. So you can see that in the input section, when there is a positive half cycle, the diode is in the forward bias condition. When the diode is forward bias, there is conduction taking place, there is flow of current which is being shown here. When the negative half cycle, the diode becomes reverse bias and there is no flow taking place. So again you can listen, when there is a positive half cycle, the diode is forward biased, there is current flow. At that time is what we get a positive half cycle here. Whereas negative half cycle is not there and we are not getting the negative half cycles. Now this shows the complete output of a half wave rectification process. The input sinusoidal waveform, that is the AC current. There is the circuit, there is a transformer here. There is a diode connected and there is a load across it. That is the output waveform is shown here, where we have only the positive half cycles. That is a rectification taking place here. Now the output DC voltage calculation of half wave rectifier is done using two formulas. That is Vrms is equal to peak voltage V peak divided by 2. Or else we can use VDC is equal to V peak divided by pi. Full wave rectifier. Now we come to the full wave rectifier section. Full wave rectifier converts the whole of the input waveform to one of constant polarity, positive or negative at its output. It is here the positive half cycle as well as the negative half cycle is being obtained at the output section, but it is having only a constant polarity. That is, either complete half cycle is converted to positive polarity or complete half cycle is converted to negative polarity. Full wave rectification converts both polarities of the input waveform to DC and is more efficient rather than half wave rectifier, because we have both positive and negative half cycles obtained at the output in the form of a single polarity. In a circuit with a non-center tap transformer, 4 diodes are required instead of the one needed for half wave rectification. The single phase alternating current, if the transformer is center tapped, then 2 diodes back to back are needed. That is, anode to anode or cathode to cathode can form a full wave rectifier. A full wave rectifier using transformer and 2 diodes. So you can see the input AC wave, and here in the circuit we have a transformer. This is a center trap transformer. We have 2 diodes D1 and D2, and here only one diode is conducting at a time. Other one will be reverse bias, and there is also a load connected here. This R is the load connected here. So when there is a positive half cycle, the one of the diodes, for example the diode D1 conducts, whereas diode D2 is in reverse bias condition. So we get only the positive half cycle. Now when there is a negative half cycle, the working of the diode reverses. The diode D1 will be in reverse bias condition and diode D2 will be in forward bias condition. This moment we are getting the negative half cycle, and this process is getting repeated, and this is a waveform thus we achieve. The formula that we use here for the calculation of the average and root mean square output voltages of an ideal single phase full wave rectifier is VDC is equal to average voltage V average is equal to 2 Vp divided by pi, or Vrms is equal to Vp divided by root 2. This shows you the output voltage of the full wave rectifier. Sort of animation is shown here. Now we come to the bridge rectifier. A bridge rectifier makes use of 4 diodes in a bridge arrangement to achieve full wave rectification. See, here you can see this is an input waveform. There is a transformer used here, and the 2 terminals, the secondary of the transformer is connected to the diametrically or diagonally opposite edges, and the load is connected to the other 2 diametrically opposite edges. This is the output of the bridge rectifier that we get. And this shows the working. That is, when you have a positive half cycle, you have the 2 diodes, the opposite 2 diodes conducting. When you have a negative half cycle, we have the other 2 diodes conducting in order to give the complete output waveform. The positive half cycle and the negative half cycle is being conducted, and you get a complete polarity, that is single polarity waveform. And thus we come to the end of this. Thank you.